When we're looking at a Venn diagram, regardless of how many data sets it has, and those data sets are represented by the circles, there is a box or a rectangle around the circle. I'll draw that in green. Everything within this rectangle is a possible outcome. So this is called the universal set, and it's usually represented by a symbol that looks something like this. There are 4 different symbols that can be used, but I find this one the easiest to draw. Every piece of data that you have that is possible is within that green rectangle. The next thing that we can look at is the circle or circles of the diagram. Now this one, we're just using one circle, so one set, just so that we can get our heads around it. The outcomes of an event happening are within the circle. So whatever that event is, that is labelled with a letter, and that will usually be A if it's just on its own, unless it is defined otherwise. Everything that isn't A, so that is the complement of A, is outside that purple circle. So the complement of A is outside of that purple circle. So that is not A. In this case, I'm going to say that A is owning a dog. Anyone who owns a dog will go inside the circle. Say I asked 100 people whether they owned a dog. This 100 would be my universal set. So that's everything within the green rectangle. If 60 people said they did own a dog, I would pop the number 60 into set A. So now I'm left with some people who don't own a dog. Think back to complementary probability. It's either red or it's not red. You either win or you don't win. So the complement to owning a dog is not owning a dog. This is the complement of A, and it's represented by this not A. It can't go inside the circle because it doesn't fit that condition. They don't own a dog, so they can't be inside the circle. So it does sit outside the circle in the confines of the green rectangle. So 100 that I know is a universal set. So I'm going to put that here. I'm going to put A is 60. So 100 minus 60 gives me 40. There are 40 people in my complement of A, or my not A. So they will go outside in the not A space. I can see that there are 60 and 40, which gives me a total of 100, matching my universal set. If you have 2 sets, like in this example, the second one may be labelled B. First off, though, I'm going to colour code this so that I know that it's the same as the other one. That green rectangle is my universal set. I'm going to label that with the sign, and then I'm going to do set A in purple like the previous example. I will label that A. So the second set, I'm going to colour that in pink, label that one B. For this, we might want to know if the person owns a cat. My first example used whether you owned a dog as set A. We're going to use do you own a cat as set B. We're going to need to be a little bit more careful with this data though. If we ask those 100 people again whether they owned a dog or a cat, we can end up with a few different answers. Either they only own a dog, which would be in this section, or they only own a cat, which would be in this section. They could own both, which would be in this section in the middle, or they could own none at all, which would be out in this section. So I'll keep A as dog, and in this version of the survey, 45 people said they only owned a dog. So I'm going to put that in purple. 30 people said they only owned a cat. So I'm going to put that in pink. 15 people said they owned both a cat and a dog. Now before I had that in orange, so I'm going to put that in. I can add up 45 and 15 and 30, which gives me 90. This means that 90 out of those 100 people are accounted for. 100 minus 90, it tells me that there are 10 people who don't own a dog or a cat according to this survey. This means that of the 100 people who we asked, 10 don't own a cat or a dog. So that means that the complement of the data is 10, and this will go outside the sets. The 2 circles together, A and B, that's called the union, and it includes all the outcomes in A or B. So that's 45, the 15, and the 30. The middle section, which is where the 15 is, that's called the intersection. And answers can only go in there if they are both A and B. The overlapping section in the middle, or the intersection, that is the and section. People have both a cat and a dog. And anything outside those circles is in the complement or not in A or B. We can see that each circle represents the relevant data. The crossover in the middle, or the intersection, tells us how many people own a dog and a cat. We can see that this does match our previous data because there are 45 people who only own a dog, and there are 15 people who own a dog and a cat. So that adds up to equal the 60 dog owners that we had in the previous example.